In this video today, I'm going to show you some new features on on Google's Notebook LM AI. I just created a video about using AI to create like Kahoots and stuff like that, and I didn't know what was going on over here. It used to be podcast, now they call it audio overview, and I didn't even know what this video overview was. I thought it was just you bring in a YouTube video and then it gives you like a summary because they used to give you like study guides and stuff like that. And I'm not sure where those are, but maybe those are reports now. So what we have here is we have this new feature called video overview. And this is an old PowerPoint that I changed into PDF, and I'm going to go through this. But this is how cool this is. I took my PowerPoint, I transformed it into a PDF, I uploaded it, we made quizzes, and you can see that video, flashcards, all that stuff. But now I found out what this video overview does today, and I'm just so excited about it. So it changes your PowerPoints, PDFs, a YouTube video, anything you can upload into here. We'll get over that in a second. And you can create a video overview or an instructional video. And I'm going to show you how cool that is in a second, but I want to show you. This was my old PowerPoint, and I have it right here. Let's see. It's this one. Motion and forces. So I took this PowerPoint, right? Has all this stuff in here, motion and forces, and really friction, has a lot of stuff in there. I would probably, if I was going to do another one, I'd make it shorter so it was more concise. And I went over here and I said, save as a PDF. I converted it to a PDF, and then I uploaded it into Google Notebook LM. I also uploaded it into Kahoots to make Kahoot from it. And I created quizzes and flashcards and showed all that. You can make a podcast, but I clicked on this video overview and it makes this video. This is a 6-minute video, so let's go ahead and take a second to watch this video and see how cool it is. And push play, and then I could download it and put it on YouTube because it's an MP4.
Ever stop and wonder what's really going on when you see a planet in orbit? Or how about something more down to earth? Like, what really determines the outcome of a car crash? Well, today,
I get a feel for Hewitt Druitt,
and that gets
right?
us to a really,
so cool.
really core idea in physics.
All right, so this is cool
constant
stuff.
Speed around a curve is accelerating,
and
changing direction.
This is phenomenal.
And how they interact with each other.
To see the entire
From the
video
orbit of a planet down to forces just
and it's done in
cancel
less
out.
than 5 minutes.
Well, the answer is the key to everything we've talked about.
So I take a PowerPoint that I used to teach kids with. This one was from like 2006. And I turn it into a PDF like I showed you. And then I just upload it. So let's go ahead and do that. So let's go here. We're going to create a new one. All right. So I'm going to have create a new notebook. I could do any of these notebooks. I'm going to say, okay, I want to upload something, but I haven't done this yet. So let's go over here and let's do this. So this crazy, this was one of the first PowerPoints I made as a teacher. I used notes. Had to write on things. I didn't have computers in a classroom. So this was the first time. This is 2006. People don't understand that. This was like one of the first times I had a projector hooked up to a computer that I could do this crazy stuff. And then here's your typical, this was made when you first started using PowerPoint presentation. Watch this. Look at that. And this was my actual voice. So I used this with Articulate Presenter back in 2006, and I created a video. So what I did was I had a PowerPoint. You take the PowerPoint, and we do this now with Camtasia Studio, all this stuff, where we just do a voiceover. You run the PowerPoint, and you do a voiceover, and now you have a video. Back then, it was a huge deal to be able to take Articulate Presenter and create a a presentation that was a video-based presentation that ran all by itself, and it had your voice. I had my voice. It was me reading, finding answers to research. A scientist does this, that, and the other. So let's get out of here, because the audio files don't even work anymore on these newer computers, because they've changed from WAV file. I don't know what happened, but none of my old like videos, like really old ones, a lot of them don't have sound in them anymore, because they had different software running it, and all that software became obsolete. Even if it was by Microsoft, which like this PowerPoint was, or Articulate Presenter, the audio don't work anymore. They don't exist, but it wasn't really that good anyway, so it's not like a big loss. All right, so let's take this file, let's save it as a PDF. All right, click Save as a PDF. Give it a second to do this. Okay, so now it's a PDF file. It's going to be in that same folder. So I would save. Now we can come back here and do the exciting part. All right, prepare. Is it ready yet? Let's take a look at our folder. Come on. Oh, yeah. Let's look at our folder. Still processing. Oh, come here. Open up. My laptop gets bogged down sometimes. All right, so let's see. All right, here we go. Good. It exists. So let's get rid of that. I don't really care about it anymore. And now let's upload it. So choose a file. It could be a TXT, a PDF, audio file, MP3. People were asking about that. And it's in my folder. So let's go back to, I think the folder's right here. There we go. Open up that folder. And here it is. Here's my PDF. So open that up and open. So what does NotebookLM do? Okay, so here we go. This was a very simple PowerPoint first section. So let's take a look. So first thing I could do is I could generate a quiz. Let's do that. We'll generate a quiz. So then it takes a couple seconds. It does that. I can create flashcards. Okay, so you do that. Now it does this. I could do mind maps. Okay, we could do that. Let's do reports. Let's just see what's going on here. Oh, I want a study guide, of course. So let's do a study guide. All right. So now we got these things being generated. Let's do a podcast. So now it's creating a podcast right there. We got everything? Audio? Okay. And here is the creme de la creme, the instructional video. So let's click on this. So we're going to generate an instructional video. And, oh, it didn't ask me what it does. So you can actually create this in different styles. And I'm not sure why it didn't ask me this time, because it asked me last time. You could do it in well, there's all different I'm sorry. There's different styles you can do it in. This will be whiteboard style. This should come out, hopefully, because it didn't ask me how I wanted it. This should hopefully come out in the same style as like you saw the last one I did, which to me is if you ever took conceptual physics, there was a guy named Paul Hewitt, and I was very fortunate to actually meet him in life at a conference and get a picture with him and shake his hand and tell him how much I enjoyed his videos for physics and all his textbook and everything I was doing. And I got the email correspondence with the work I was doing. I don't know if he was lying to me, but he said he loved how I was creating animations with his from the material in his textbook. So it was a big deal for me to meet Paul Hewitt and to be able to have a correspondence with him through email back in early 2000s, between 2006 and 2010 type of thing. So anyways, what we have here is we can look at, okay, let's look at some of this. Let's look at the flashcards as we're waiting for this stuff to go. Let's look at the flashcards and see what is the definition of science according to the source material. All right. What is the key? Oh, see the answer, flip it. All right. Through research and experiment. So what is the key way scientists find answers? All right. So these are flashcards. Okay. So what can we do? We could share these, right? We can have students go through this. All right. I could create something like this on Quizlets, because I have a Quizlets account to create flashcards like this. But who discovered X-rays by repeating cathode? I don't know. Oh, that's nice. That was in my thing. I did not. Oh, here's a blank. There you go. Scientific method of inquiry. There you go. So, okay, here's all this stuff. So here's this stuff. That's great. Let's see. Get rid of this. All right. So then we got, let's look at our study guide. All right. Here's a study guide. Here's a short answer quizzes. So I don't know if you've ever done study guide. I've done it before. This stuff is so awesome. Essay questions, glossary terms, all this stuff came out of my PowerPoint. All right. So this could be, when we get this video that's being produced, these questions should go along with what's in the video. All right. So what do we got here? So copy content with formatting, so we can turn this into a Word document. You could also have, if you're at a Google school, oh my goodness, if you're at a Google school, all your Google Docs, if you had all these Google Docs for all your things, are just directly right into here with your Google account. Okay, so this is my Google account, right? So we did our study guide, we did our flashcards. What's this? This is our mind map. Okay, let's take a look at this mind map. Ooh, look at that. Where does science go? Oh, isn't that cool? Ooh wee, look at that. All right, so this is stuff I don't do, but wow, it's kind of cool, isn't it? And it does it for it automatically. So let's get rid of that. You can download it. Let's get rid of that. You can download it. Oh, come on, I want to get rid of it. Here we go. Right up here. All right, so we got that. So this is good too. These science quizzes. So Google Gemini has study mode, and this is like a study mode. So it generated a quiz, and it's got these questions I get to pick. Based on the definition provided, science is fundamentally described as a knowledge applied to the natural environment through which primary activity. Okay, so we have careful observation. Let's take a look at, let's see, is that right? Oh, that's right. It tells it's right. Let's see if we can get the next one incorrect. So these are nice quizzes, and they give you right or wrong. Let's see. I'm not going to look. Developing a practice. Oh, creating technology, applicable convert. See? So this gives you, and there's the right answer. Wow, isn't this great for students? If it's just it's just something for them as a study guide to learn. You can pick things, you get explanations. All right. So these questions are great. These are great questions. They can be cleaned up a little bit. My PowerPoint was terrible. So that's why this quiz isn't as good as the one that you saw earlier when I did my other video about Kahoots and the quiz questions that produced. So this is great. So let's get rid of that. So let's see what we got here. So, all right. So we got our science quiz. We have our study guide. We have our flashcards. We have our mind maps. And we're going to wait for this. This is going to take a while. So we have our podcast, which I have other videos that demonstrate how to do that. And we have our video that's going to be generated. Now I want to go back over here let's go back here to our front. And all right, so property to wave note guides. So also, I forget to say, I like to put things down here too. You can write anything. So this is like let's do this wave overview, video overview. All right, this is just generating a video. Let's see what we can do here with this video. Decoding the universe. All right, so I've created podcasts, and here's a podcast from this thing on waves. Let's see what we got here.
Okay, let's unpack this. We're constantly surrounded by waves, aren't we? They carry pretty much all the information.
And this is cool. You see
they
this
really
interactive?
do, from sound to light to.
So I'm interrupting as they
Exactly.
speak.
But if you stop and think, what
also.
actually is a wave?
So
it sounds simple.
Listen to
but
the
answer can get a
podcast,
bit
and now we
murky.
could actually be like a caller.
So today we're doing a deep dive. We're taking those tricky scientific ideas and giving you a shortcut.
A shortcut to really get the essentials, the properties that define how energy moves, whether it's sound or light or anything else.
Precisely. And our mission starts.
Let's see what happens here. Okay, I'm going to record this. Play audio. Two hosts. Carry a shortcut. Let's say play audio. Oh, join.
Okay, let's unpack this. We're constantly surrounded by waves, aren't we? They carry pretty much all the information we
but
get.
now
really do,
I could be a
sound to
caller
light
to
to,
call in the
how your phone
podcast,
works.
which is even cooler.
But if you stop and think, what actually is a wave? It sounds simple, but the answer can get a bit murky.
It can. So today we're doing a deep dive. We're taking those tricky scientific ideas and giving you a shortcut.
A shortcut to really get the essentials, the properties that define how energy moves, whether it's sound or light or anything else.
Precisely. And our mission starts with, oh, hey, our listener wants to join in. What's up?
Hey, you just mentioned how waves can be sound or light. What is the difference between sound waves and light waves? I have no clue. Oh, use of microphone is unavailable. Okay, I'm sorry. So, Note wants to, yeah, okay. Allow, let's do allow this time. Hello, can you hear me? I want to know what the difference is. It's not doing it yet. Okay, here we go.
Hey, yeah, what's up?
Hey, how are you? I'm trying to figure out what is the difference between sound and light waves.
Hello? Yes, we can absolutely hear you. Welcome. We are doing great. Thank you for asking.
We love it when you chime in. You are asking for the very core of our discussion today.
When you ask what is the difference, you are hitting on the most fundamental distinction in wave physics.
It's excellent because it makes us jump right into the two main wave types, mechanical and an electromagnetic.
Sound waves and light waves are the perfect examples to compare those two categories.
The key difference is what they need to travel.
Sound waves, for example, are mechanical waves. They require a medium to transport their energy.
That means sound needs matter like air, water, or a solid for those particles to vibrate.
This is why sound cannot travel in a vacuum. No particles, no sound.
Light, however, is an electromagnetic wave. It does not require a medium.
Light travels readily through the near vacuum of space, right? Which is why we see the stars.
Exactly. Electromagnetic waves are special because they combine an oscillating electric field and an oscillating magnetic field.
So sound needs stuff to...
Yep, go on.
Oh, you just blew my mind. But I heard that light or electromagnetic waves could be a particle or a wave. How does that work?
Oh, that is a fantastic question.
That's where it gets really interesting, diving into quantum physics.
That concept you're referring to is called wave-particle duality.
Yeah, and it's key to understanding light and all electromagnetic waves.
Essentially, light exhibits properties of both waves and particles, which we call photons.
So when we talk about light traveling, sometimes it behaves like the wave we just described, oscillating and propagating.
And sometimes, when interacting with matter, it behaves like tiny, discrete packets of energy, the particle.
It doesn't mean it's both simultaneously, but rather that its nature depends on how you observe it.
For the scope of today's deep dive, however, we are primarily focusing on the wave properties.
Right, we're looking at the ways energy travels across space, which is primarily a wave phenomenon.
But we absolutely appreciate that you brought up the duality. It shows you're thinking critically.
It's a great reminder that even these simple concepts have deeper quantum layers.
Now let's bring it back to the macro scale of wave behavior.
So as we were saying, sound needs stuff to wiggle, and light just carries its own fields.
If we connect this to the bigger picture, light travels through space, but sound does not.
So now what you saw happen was it supplemented in this questions I was asking it in the conversation, but then it went back to the original podcast. So it seamlessly went away from the podcast and then back to it, which is incredibly awesome. I can't imagine if I had students. I have these podcasts. I already created these podcasts. This is one of them that I was talking about. And I said, you could share these, right? I could share this and they could have NotebookLM, right? And they could ask questions as the podcasters are explaining my PowerPoint presentations to them. That's insane. Now let's go back and see if our video has finished being created. So what were we talking about? Fundamentals of scientific inquiry. Okay, this is what I had. All right, so let's see now. Where is this? All right, so where is the podcast? Oh, here we go. So let's listen to this podcast. Once again, we can interact. We have interactive mode, but I just want to listen to it.
Welcome to the deep dive. Today, we're not chasing the latest headlines. Instead, we're stripping everything back, right down to the bedrock. We're doing a deep dive into the fundamentals of how knowledge gets built, how science actually works, how an idea gains credibility and eventually changes your world. Yeah, the source material we're looking at, it's this really interesting set of foundational notes. They define the methods, the duties, even the hierarchy of scientific understanding. This isn't just about vocabulary lists. It's more about understanding the blueprint, sometimes a messy one, behind how we create knowledge today.
Exactly. And our mission here really is to get past those simple textbook definitions. We want to understand the process. How does an idea, a testable statement, grow? How does it evolve through sheer rigor into something fundamental, something that can actually reliably predict what might happen next? We need to grasp that ladder of knowledge, from a basic hypothesis right up to a scientific law.
Okay, let's ground this right away. When we talk science, what are we really talking about? It's knowledge, right? Applied to the natural world through really...
So I want to add that I consider the PowerPoint that I turned into PDF horrible. Like I said, it was one of the first PowerPoint presentations I ever made. It kind of blows my mind with technology right now that I went from a place, you can see on my YouTube page, where I had to write on a clear piece of plastic with a Sharpie marker to give notes to people, to present to people, to writing on a chalkboard and only having chalk and a chalkboard and that's it, to finally having a classroom that had a projector that was hooked up to a computer. Wow, that blew my mind how great that was. I could create PowerPoint presentations for the first time in 2006 when I was teaching. And now I can create these videos from just notes. It could have been just text notes. It could have been a paragraph copied from my textbook, turned into a PDF, and then uploaded. So let's see what this video looks like. All right, let's push play.
So, what is science, really? I mean, it's a word we hear all the time, right? But have you ever really stopped to think about the incredible journey an idea takes? How does some little observation in a lab become the technology that, powers our everyday lives? Well, that's the exact path we're going to trace today. Just think about the microwave in your kitchen. It feels so normal, so ordinary, but it's actually the final chapter in a really long story of scientific discovery. A story that starts with a simple question and ends up with a hot meal in like 2 minutes. So how does that even happen? Let's break it down. All right, first things first, what are we even talking about when we use the word science? At its very core, science is just knowledge about the natural world, and it's knowledge we get through careful observation. But here's the key. It's not just about collecting a bunch of facts. The real magic happens when that knowledge gets applied. That's the bridge that takes us from some abstract concept to a real-world tool, like that microwave. It just goes to show you, sometimes accuracy. So, to put it really simply, a theory is the explanation. It's the why. A law is the description. It's the what. So a theory of gravity explains why an apple falls, while the law of gravity describes exactly how fast it's going to fall.
This is insane to me. And I'm telling you right now, my PowerPoint presentation was horrible. I have such better PowerPoint presentations now. I have for every topic I taught, I probably have 10 or 15 PowerPoints as I went through them of my career from 1996 actually, when I started internship, all the way. Well, actually, I didn't have PowerPoints back then. Like I said, from 2006 to now, every topic I taught in physics, chemistry, earth science, I probably have 5 to 10 different PowerPoints, totally different for the content. And even when I first started creating a web page before I had PowerPoints, I had created pages and pages of notes for the entire physics course that I had that were just page notes that were online for students to do. And this is the bare essentials, and it's created this awesome audio video presentation on my material, taking knowledge from the internet and from better presenters than me and creating it. And like I said, for some reason I couldn't show you the styles that I saw earlier, but you can pick out of like 8 styles how you want this to present. This is called the whiteboard style, as if I would just had a whiteboard and was drawing things. And like I said, I love this style because the first time I saw it, even the fonts look like how Paul Hewitt used to draw his Hewitt Drew It physics cartoons. So this is awesome to me. This is really awesome. Well, I hope you enjoyed what I did today, and I hope that it was useful for you. And I hope you enjoy using this knowledge to further the students' learning processes. Have a great day.